Okay, when you are multiplying fractions, you would multiply the numerator and multiply the denominator. So, if you don't remember what these words are, the numerator is the top and the denominator is the bottom. And you know how I always remember it? North Dakota. That's how I always remember what was what. North Dakota. Okay, so what do I mean by that rule? This is it. So what's the top times the top? 10 over 21. Okay? So same thing, multiply the numerators. 54 and 16.
Reciprocal.
Okay, division. Change the division to a multiply. Then reciprocate the fraction that, how do I want to say that? Comes last. That was the divider. I don't know, I should have just said the second fraction. So the process of divide by something becomes times by the flip of it. So the word reciprocate, you're just changing it like that. Okay, so you keep 8/5, you keep it. Don't do anything with it. Divide becomes times and reciprocate. Okay, I want you to think about this for a second. If you divide something by 2 and you half something, does that mean the same thing to your brain? Okay, if you have $30 and you get half to keep half of your money, you get $15, right? Or 30 divided by 2 is 15. That's the same thing. So dividing by 2 and timesing by 1/2, I just said were the same thing. So you can see the flip multiply thing. Do you see it now? Does that kind of make sense to your brain? Okay, this is a problem, this last one, because of this. This is called a mixed fraction because there's a whole part and a fraction part. Okay, so you're going to go 1 whole with 2 parts is how many parts right now? 2 plus an additional 1, 3 over 2. So you're going to keep the first one, multiply, and now you can flip that. Okay, and this is great. I like this answer, but if you wanted to, you could do some reduction with something like this. So a reduction means what could I possibly divide this number and this number by? 2. I could also do 6. I could also do 12. So reducing the most would be dividing by the most you can. So if I divide each by 12, okay, and you could have done that with this fraction as well, right? Because they're both even numbers, so I know for sure.
Would you always want the lowest?
No.
No. So whichever one's fine?
Yeah. Do you guys know how to tell if a digit is divisible by 3? Okay, if I just pick any number in math, if I look at this one, I know without my calculator that it's divisible by 3. And this one is not divisible by 3. I can tell you that without my calculator. Okay, here's the trick. What does 2 plus 5 plus 5 make? 12. Is 12 divisible by 3?
Yeah.
Yeah, that's it. What's 1 plus 7 plus 2? 10. Is 10 divisible by 3? No. Okay? So there's a trick. So 253, we said should be divisible by 3. 172 should not. Okay? So there's something you can now use for just mental math stuff, knowing if something is divisible by 3. So that can be a trick on reduction stuff. Okay, adding and subtracting. Okay, you must find a, big idea here is common denominator before you add or subtract things together. So a lowest common denominator is a lowest common multiple. That's what you're kind of trying to find. Okay, so denominator again, you're looking at the bottom. So a 7 and a 3, what kind of number could I change them into that they're both going to be able to divide by it? 21. So I'm going to turn them both into 21s so that they match. Okay, so now I can go through this process. What did I do to the 7? What did I change it by? I multiplied it by 3. So I will do the same thing from the bottom to the top. You got to do the same thing so that it's matching the fraction. Okay, then this bottom, how did I go from a 3 to a 21? Multiplied by 7. So that's 14. Okay, and then you can add the top, so 29 over 21. You do not add the bottoms. Okay, you have to think about if I did this. Something simple, 1/4 plus 2/4. So if you think about eating pie like that, that's just 3/4, right? You're not changing the bottom. Okay, so here we have to think about an 8 and a 2. What's the smallest number in math that will work for both of them? Go ahead, Easton.
The smallest number?
Smallest digit.
Well, you could, well, it would be 8.
It would be 8. Yeah. Yeah.
Door.
Someone's at the door.
There's a bag there.
There you go, my shirting's half on. There you go. There you go. That way you can do your grocery shopping. Thank you.
Okay, is it wrong to pick 16? No. It won't, but like in a future kind of math course, if we have to worry about reducing, now we're going to have to do that. Okay, so I'm going to get you to start already thinking. Try to think of the lowest, lowest, lowest. Okay, so this first fraction had an 8, so I didn't have to do anything, so I don't have to do anything to the top. 2 turned into 8 because I multiplied it by 4. Okay, and we're practicing this without our calculator because I'm going to have that as your test without the calculator, these kinds of numbers. What'd you say? Oh, thought I got something wrong. You were going to correct me. Okay. So you look at a 5 and a 2 and you're trying to pick the lowest digit that you can turn them both into. So that would be a 10. So I'm going to have to times this by 2. I'm going to have to times this one by 5. Ooh, integer stuff. This is a 16 positive and this is a negative 35. So remember last time when you're... Oh, what?
How is it a negative 35?
That's right, I got that too.
Because I have to times it by 5.
Yeah, then that's positive?
No, because this is a minus. I'm going to have
But
to...
aren't you subtracting 8 over 5? Or aren't you subtracting 7 over 2 from 8 over 5?
I'm subtracting that from that, yeah.
So then how is it a negative?
Because this is this one. I didn't switch places.
At the bottom, 16 minus 35.
I doubled this one. So that's the 16 and that's the 10.
I get it. Okay.
You're good? You found your thought process?
Yeah.
Okay, so think about your digits like this last time, right? If this is a plus and this is a minus, we would actually take the difference of them, their values. So what's 35 minus 16? 19. Would you have more positives or negatives? More negatives. Okay, and this last example, this I don't like again. So if you have one entire pie with 8 pieces, that's already 8 pieces, and then 6 more, 14. And then what am I going to turn them both into? I'm going to make them both 8s. Yeah. You can never go lower than any of the digits there. You always have to be at or above, right? Multiples. So 14 stays the same. And this would have to get times by 4. Okay, now again, I'm at the same integer math here. I had a 14 to go with a negative 36, so I'm going to have to figure out the difference of those numbers. So what's 36 minus 14? 22. Would you have more positives or negatives? More negatives than you would positives.